day 1 of Unit 11, Comparing Functions. So up until this point, so the functions that we're going to focus on are going to be linear, quadratic, and exponential. So this will be a little bit of review, but now we're taking multiple functions, equations, and we're trying to compare them. Alright, so the first thing I asked you to do was I wanted you to match each graph to the correct graph. I'm sorry, to the correct word. Okay, so if we think back to what a straight line is called, we know that that one is linear. I put little lines for you guys. This one, we've only been doing this for the past couple chapters, so hopefully you know that that's a quadratic. This one gets very close to 0 and then shoots right up. That's called exponential. And then lastly, we know this lovely graph that makes a little V for absolute value. Okay, and then also on your paper I have your parent functions. So remember, usually function notation, we have an f of x. So if it's a linear, now this is the parent functions, so it's not actually for these specific graphs. This would be x squared, so these would just be the very basic. And this would be b to the x. Remember, b needs to be greater than 1. And the absolute value f of x is equal to absolute value of x. Just to go back to your exponential, just remember we can actually go, let me fix this. Remember, we can go from 0 to 1. So it can be, alright, what I want you to write, so b is less than 1, it's a dk, and b greater than 1 is a growth. So we'll talk about that a little bit more, or review that more, that's not new. Okay, so again, if it was less than 1, it would look like this. Okay, or if you could just add that. I know I have this on your paper, so just write that that's a growth and then add the constant between 0 and 1, that would be a decay. Remember, if it's negative, that just means it flips. So just make sure you add that to your page. So the next thing we're going to practice is how we can figure out the type of function that is modeled based on a table. So there's a couple different things we can do for this. So I'm going to show you two different ways. So the first way is if we look right here. So as x, so we are adding 1, adding 1, adding 1, adding 1. On this side, we are subtracting 4 each time. Okay, so since we can add or subtract, we can see that the common difference is -4. So since we can add or subtract by a constant, this is a linear function. Okay, now if we went one step further, Okay, so this is linear. So what we can also do is we can write down the functions. Color. We can actually write the function's equation. So if I look over here, okay, this is the y-intercept. So since it's linear, remember it's going to be y equals mx plus b. So I know that the y-intercept equals -3. So I'm going to say y equals, I'll leave a space for m is slope, remember, and then I'll do -3. So if you look over here, remember m is equal to the change in y over the change in x. So m must be -4/1 or just -4. So -4x minus 3, that is actually the equation. So we not only told the function, but we also gave the equation. And just notice on your paper, you have all the tables up top, and then you have a little section where you can do all the work that I did in pink. Oh, sorry. Okay. So just make sure you keep that nice and organized. All right, next one. So whenever you're looking at your x, you're always going to, notice if it's adding or subtracting, going up or down. The next thing you notice, okay, so 1 to 3 would be adding 2, 3 to 6 would be adding, or 3 to 9 would be adding 6. So that doesn't look like that would be a common difference. So let's think of another way we can get there. Hopefully you're recognizing, oh, I can multiply by 3 each time. Times 3 times 3. Okay, so this is called the common ratio. So that means we can multiply by a constant amount, and this would be called exponential function. Now remember, if you wanted to, you could always whip a graph out, plot these points, and that would give you the answer. Okay, so an exponential function is going to be y equals a times b x. So remember, for this one, b represents the common ratio, and a represents the y-intercept. Okay, blue. So here's my y-intercept. So this would be a. So my equation is just going to be 1 times 3 to the x power. Here we go. And of course, if your y-intercept is 1, you can always just leave it off and just write it like that. Alright, so hopefully you notice that we're doing all different examples. So this one will probably be different. So let's see, plus 1, plus 1, plus 1, plus 1. Alright, so if we add or subtract to get to the next one, let's see. So I know that I can't multiply to get the same thing. There's nothing that I could possibly multiply by. Okay, so when you're checking these, remember you're going to go backwards. So if I do negative 0.25, I'm not going to be able to do that one. So negative 1 divided by negative 0.25, that equals 4. Negative 2.25 divided by negative 1. Alright, so we know that we can't multiply to get to the next thing. So let's see. So I know that to get from 0, so negative 0.25 minus 0. So I'm subtracting 0.25. Negative 1 minus negative 0.25. Okay, so then I subtracted 0.75. 0.25 minus negative 1. That one I subtracted 1.25. And in the last one, 2.25. Oh, that's negative. Okay, so clearly I'm not doing the same thing every time, but let's see what happens. I'm going to just write those down. Okay, so first I had to subtract 0.25. Next, I had to subtract 0.75. Subtract 1.25, and finally subtract 1.75. Okay, so this means it's not linear because they're not all the same. Well, what we didn't talk about yet is if you continue. So let's look at this. Okay, if I go from negative 0.25 to negative 0.75, I actually subtracted 0.5. Let's keep going. If I go from negative 0.75 to negative 1.25, I subtracted 0.5. Oh, look at that. Okay, so this means the second difference. Okay, so think second means 2. So if I do the difference once, that would be linear if it worked the first time. But since it didn't, I'm going to try it again. Now remember, make sure that you can't multiply because that would be exponential. But if you can't do that, then try the second difference. So the second difference is negative 0.5. which means that this is a quadratic. Okay, so this is a quadratic function. Okay, so you might think that this will be kind of challenging to write this equation, but it's actually not. So y equals ax squared, where a is just the second difference. Okay. Oh, I lied. Sorry. That's not true. Losing it on a Monday. Okay. So in order to find a, what we're going to do is we're going to pick a point. Okay. So I'm going to use, so you don't want to use 0 because that's not going to be helpful. So I'm going to use this point because there's no fractions. Okay, so y is equal to negative 1. So we're solving for a for this one. Okay, and then x is 2. Okay, so I get negative 1 is equal to 4a divided by 4 divided by 4. So a equals negative 1/4. So my solution is y negative 1/4 x squared. Oh, that's my final answer. So here's a summary of how we would figure out linear, quadratic, and exponential. The first thing, of course, you have to use the table in order to figure out what the actual type of function it is. Is it linear, is it quadratic, is it exponential? So you would do the same exact thing. So again, this when I talk about that. So that's or not double, the second difference. Okay, so you're going to do that twice. And remember, just because it's called the second difference, you may be adding. Just depends on how the numbers are going up or down. Okay, so with this one, again, you need the slope and the y-intercept in order to find your equation for a linear equation. For the quadratic, you just need to plug in a point for x and y and then solve for a, and you'll figure it out. And then for the exponential, this would mean you would multiply on the table. So remember, whatever you are multiplying by each time, that's called your common ratio. And then your a value is just going to be your y-intercept. So when is x equal to 0? Okay, so pages 3 to 4, you're going to do in groups. This would be numbers 1 through 6. And we will go over them. So as soon as you're done with 1 through 3, we'll go over those, and then if we do not finish 4 through 6, that will be homework. Please let me know if you have any questions.